All right, we're moving into chapter 12, trig, formulas, and identities. You can take a whole class in trigonometry, and we are going to compress quite a bit of it into the chapter 11 we just did. And even, I guess we did chapter 10 with SOHCAHTOA, right, and law of sines and law of cosines. And then this chapter has all of these formulas and identities. For the most part, you will not be asked to memorize any of these. That's why I'm giving you this formula sheet, because you can tell there's quite a few of them. And I didn't even include everything. But I did include what I intend to focus on in your class. So that being said, some of these should be familiar. You guys know that cosecant is the inverse of sine. However, the way that we have looked at that is instead of saying that it's opposite over hypotenuse, we said it was hypotenuse over opposite. But you're pretty familiar with the 1 over being inverses. Now, this first lesson is all about forcing you to start looking at these trig identities and getting comfortable with them. And simplify is just that. If I gave you 3 plus 3, you would know that you could simplify it to 6. We're trying to make it as small as we can. And so that's what we'll do with these first 3 problems. Now I look at cotangent. Here it is. And I'm going to come over to my formulas and identities, and I'm going to look, and I'm going to see what does cotangent equal. Cotangent equals what? Cosine over sine, doesn't it? All right. So I can replace that with a cosine over sine. And then I have this times sine of x. If you would like, if you feel better, you can say that's over 1. And then wouldn't your sines just cross cancel? And we are left with cosine of x. Next. And I'll tell you right now, there is never only one way to do these problems. We can get to the same answer going in different directions. So if you hated the way I saw it first, don't stress out. Secant. What does secant equal? Secant is 1 over cosine. All right. 1 over cosine over, what does tangent equal? Come over to my sheet. Tangent equals what? Sine over cosine. Now I've got a fraction divided by a fraction. How do I divide by a fraction? Flip and times. So times by cosine over sine. Can my cosines cross cancel? Absolutely. And now I have 1 over sine of x, but that is not the most simplified version. We won't get a right answer with that because I look over at my formula sheet. What does 1 over sine equal? Cosecant. Are you kind of getting a feel for what they expect you to do on these first three problems? Let's do one more. Cosecant. What does cosecant equal? Cosecant is 1 over sine. 1 over sine times the cosine of x when I times those together, because nothing canceled, I get cosine of x over sine of x. Now that feels familiar. I feel like I saw something like that on my formula and identity. Looking for cosine over sine. Where is that? Cosine over sine is cotangent. Oops, I put theta instead of x, but put it back in terms of the variable we started with. Those are friendly. They're not horrible. These are a little more labor intensive. We went from simplifying to now we are proving. And I'll show you how to do that in ALEKS as well. Now, with these identities, we are also going to add the Pythagorean identities. Now, because these are equations, can I also say that sine squared of theta is 1 minus cosine squared of theta? Can't I isolate the sine? Therefore, can I also say cosine squared of theta equals 1 minus sine squared? So you can manipulate these, right? You can always isolate the term you want alone. So know that. That will come in handy. As we're doing these problems, we will justify our steps. What I discovered in ALEKS is they call this property right here the quotient property. They're taking tangent and they're turning it into a division problem, and a division problem is a quotient. Now, I will probably be writing pretty small on these, so if I need to zoom in more than I have, let me know. All right, I'm going to look at this problem, and this feels like something I could replace. Let's look at our formula sheet. What does 1 plus tangent squared equal? There's 1 plus tangent squared, and it does. It equals secant squared. So cosine squared x, we have changed that to secant squared x. And what property did we use? We used a Pythagorean. So we'll justify that with Pythagorean. Now, I did not do a very good job, so I'm going to backtrack. We are trying to take whatever is on the left-hand side of the equation and make it equal the right. So I am trying to combine everything I can combine here to equal 1. That's my goal. All right. Secant squared. What's the inverse of secant? How can I rewrite that? Secant, the inverse is 1 over cosine. All right, so I've got cosine squared x times 1 over cosine squared x. What property did we use when we just did that? pulled it out of this square, and so it is reciprocal. Good. What can I do to this now? If you need to see it, put that over 1. Yeah, I can cross cancel. Gone, and I'm left with 1 equals, that's what we wanted in the very beginning, right? And that canceling technique that we just used, Alex will have you justify that saying I used algebra. How did that feel? All right, let's keep going. Let's see. 1 minus sine squared x, what does it equal? 1 minus sine squared x equals cosine squared. So I'm going to leave this guy. That's going to equal that. What property did I just use? Came out of the Pythagorean identities. Secant squared, how can I rewrite that one? Secant is, 1 over cosine, perfect. So 1 over cosine squared x times cosine squared x. Now I know it feels like we could have done those at the same time, and yes, we sure could, but I can't justify them with the same reasoning. So we've got to do them one step at a time. That was the reciprocal, good. Then we're going to cancel. We're left with 1 equals 1. Why? We used algebra. Those were pretty friendly. And the next ones kind of grow in intensity. Of course they do, right? All right. How can I rewrite cosecant? Whoops, there it is. How can I rewrite cosecant? 1 over sine of x. Thank you. Minus. How can I rewrite cotangent of x? Oops, you know what? I've got to justify it. That's a different reasoning. So that was reciprocal. All right, now how can I rewrite tangent? Cotangent is, I think I want to use this one. And you're right, it is 1 over tangent. You're absolutely right. But because I've got sines and cosines going on,
You want to work?
yeah, I think I want to work with that. So that would be cosine over sine, and then times that original cosine I had. And that would be, so I went from cotangent to cosine over sine, and we said that's going to be the quotient property. What's x times x? X squared. So guess what cosine of x times cosine of x is? We say it cosine squared of x. So I could rewrite this as, I'm going to get a common denominator because they're both sine of x. And I'm going to say that's 1 minus cosine squared of x. How did I get there? I used some algebra. One minus cosine squared x sure feels like it should equal something. I'm going to come and I'm going to look over here. 1 minus cosine squared x, what does it equal? Sine squared? So now I can say that that is, I'm running out of room, sine squared x over sine of x. What property did we use? Pythagorean. What's x squared divided by x, you guys? Don't they just cancel each other out? So that squared will cancel with that. And I'm left with sine of x. How did I get there? I used algebra. Was that one uglier? For sure it was uglier. We had to get a common denominator. That made everything harder. And then I needed to see that I could go with the Pythagorean identity. But I think the fractions is what made that one hard, getting a common denominator. In fact, let's practice getting a common denominator for the sake of time and sanity, because these are kind of overwhelming. I'm going to skip this problem, and we're going to move down to these bottom two. If I want to get a common denominator out of those two, it would be sine of x times 1 plus cosine of x. So what would I have to times that first fraction by? 1 plus cosine, and I would need to times this one by, it doesn't have sine. Do I need to put the 1 times on this, you guys? For sure not. I can say that's 1 plus cosine of x minus, what sine of x times sine of x? Sine squared of x, yep. How did I get there? What did we use? Didn't we just do algebra? That's all we've done so far. We got a common denominator. I don't have an identity for 1 plus cosine. Do I have an identity for 1 minus sine squared? Is there an identity for 1 minus sine squared? I move that to the other side. 1 minus sine squared equals cosine squared. So I can say that equals cosine squared x. And I still have that other cosine x. Here's my common denominator. And we used the Pythagorean identity. Now here's the trick on this one. If I were to factor out a cosine of x, out of the top. Look at what I did here. Let's make sure you understand what I did. So I pulled out one cosine out of this. Here it is. One cosine divided by that is, did I write that the wrong way? I wrote it backwards. But this divided by this is 1. This divided by this is cosine of x. I wanted it to match my bottom, so I flipped it in my head. What do you have the same on the top as you do on the bottom? 1 plus cosine of x. Whoops, I didn't justify that one. What did we use? We did some, what's that? Algebra. Yep, that's exactly what we did. And now I have cosine x over sine of x. We should be thinking, that sounds familiar. Cosine over sine equals what? Cotangent. And what property is that? Quotient. How you guys feeling? Now, this one over here has a trick. There is no way for me to pull this fraction apart. I do not have an identity that says 1 plus sine of x equals something. So right now I'm stuck. I can't get to where I need to end up. I have that 1 plus, and here's your secret. It's a word we haven't used for a long time. We're going to use the conjugate. When we have a denominator that we're struggling with and it's a sum or a difference, the conjugate is our best friend. So I'm going to take that fraction, 1 plus sine of x. Do you remember what the conjugate looks like? It's the same thing, but change the sign in the middle. 1 minus sine of x. Let me close that parenthesis. Now, I'm going to multiply this all in one step because all I'm doing is algebra. So we might as well simplify this. I'm going to distribute this through. So I'm going to have cosine of x minus cosine of x sine of x all over. Do you guys remember what happens when we FOIL conjugates? First is 1. Outside is minus sine x, inside is plus sine x. Your outside and inside will always cancel. So all I need to do is multiply the first and the last. That was a whole bunch of work, and all we did was algebra. That 1 minus sine squared x sure feels familiar. 1 minus sine squared of x equals what? The numerator is going to stay the same. 1 minus sine squared of x equals, did you guys already look it up? Cosine squared. That property is the Pythagorean identity. Now, I'm out of room on my paper for what I want to do in my head, so I'm going to show you what I'm doing in my head, and then we'll just write the shortcut on the paper. Because of this difference right there, remember, this is dividing here and here. So what I've got is cosine x over cosine squared x, and I also have cosine x sine x over cosine squared x. So this is just like if I had an x over an x squared, what happens? I'm left with the 1, right? So this cosine cancels with the square, and I'm left with the 1. This cosine cancels with the square. All right, so now I want to write that simplified version right here. So we said we're going to end up with, goodness gracious, 1 over cosine. And then we had what? Sine over cosine minus sine over cosine? What did we do there? Didn't we just do some algebra? What does 1 over cosine equal? Secant, perfect. So then we've got secant x minus what's sine over cosine? Tangent. Yeah. And isn't that what I was going for? What properties did we use there? 1 over cosine is the reciprocal. And from sine over cosine to tangent is the quotient. So know this. On your homework, they will make you do this step and justify it. And then they'll make you do the second step and justify it. Because it will have a drop-down menu that lets you select the property and identity that you used.